my name is Tia, and this video is an introduction to continuity. First, we'll do a warm-up, then we'll learn what continuity even is, and then types of discontinuities. Start off with a quick warm-up. Pause the video here to work on it on your own. The first part asks us to factor the rational function. The numerator is x squared plus 5x plus 6. When this is factored, it becomes x plus 2 times x plus 3. The denominator is x squared plus x minus 2. When this is factored, it becomes x plus 2 times x minus 1. So our final answer is x plus 2 times x plus 3 all over x plus 2 times x minus 1. Part 2 asks us to identify any holes, vertical asymptotes, and horizontal asymptotes. Holes occur when factored components cancel out, which means they divide to 1. Here we can see that the x plus 2 repeats in the numerator and denominator, so we know that there's a hole at x minus 2. Let's find the vertical asymptote. A vertical asymptote occurs when the rational function is undefined, which means that the denominator is equal to 0. To figure this value out, we must set the denominator equal to 0. Because we know that there's a hole at x equals to negative 2, we can cancel that out and then solve for x. And we know that there's a vertical asymptote at x equals to 1. Now moving on to finding the value of the horizontal asymptote. There are numerous rules to finding the horizontal asymptote depending on the degree of the numerator and the degree of the denominator. But in this case, the degrees are equivalent, so we must divide the coefficients. Both coefficients are equal to 1, so we do 1 divided by 1, and we know that there is a horizontal asymptote at y equals to 1. For the final part of the warm-up, we need to make a sketch of the function. In blue, there is a recall box with crucial components that the sketch must include. To create a sketch, we'll be making a table of values and then plugging in x values. Now you can utilize the calculator and plug in the values. It's important to note that at x equals to negative 2 and at x equals to 1, there will be either an error message or it'll say undefined because there is a hole and a vertical asymptote there. So let's draw in the asymptotes now. We have a horizontal asymptote at y equals to 1, and then we have a vertical asymptote at x equals to 1. Now we can add the points from the graph starting at x equals to negative 3. Now we can just connect the dots, and we have a beautiful looking sketch. Now that we have a rough sketch, we can add in the hole. A hole is denoted by an open circle, and I just added it where x equals to negative 2. Let's move on to the learning content for this video. The meaning of continuity in the traditional sense is without interruption. In a more mathematical sense, a continuous function means a function without any abrupt change in value. These abrupt changes are called discontinuities. Let's examine this function's continuity. The blue dotted line represents a vertical asymptote. Is this function continuous or not? This function is not continuous. This is because we can see multiple abrupt changes in value. Let's work on this from left to right. At first, we can see that there's a closed circle and an open circle. The value of the function immediately jumps from bottom to top. The next abrupt change is right there where there is a hole. From pre-calculus, we know that at a hole, the function is undefined, so this is an abrupt change. The next abrupt change in value is at the vertical asymptote. We can see that from the left side, it goes upward toward positive infinity, but on the right side, it goes towards negative infinity. So this is an abrupt change as well. I listed out all of the abrupt changes for the sake of exemplification, however, only one abrupt change is necessary to deem the function as not continuous. Now moving on to the final part of the video where I'll explain the different types of discontinuities. Discontinuities are essentially things that make the function not continuous. They do this by causing an abrupt change in the function value. The first type of discontinuity is an infinite discontinuity. This occurs where one or both of the one-sided limits goes towards infinity. So it goes up or it goes down. The second type of discontinuity is a removable discontinuity. The removable discontinuity is a type of discontinuity of functions that occurs at a point where the graph of a function has a hole in it, so that open circle. The third and final type of discontinuity is a jump discontinuity. The graph of the function will show a jump or a gap between segments of the curve. It's important to note that the one-sided limits are not the same. They both approach different values. Let's look at the three types of discontinuity side by side. The jump discontinuity and the removable discontinuity often look very similar because they both have holes, and a removable discontinuity also often has an external point. There is a key difference, however, that occurs every single time. When a jump discontinuity occurs, the right and left limit of the function as x approaches the discontinuity are not equivalent, whereas in a removable discontinuity, the right and left limit of the functions are equivalent. And finally, there is the infinite discontinuity, which is set apart from the other discontinuities by its vertical asymptote. And that is it for this video. Thank you so much for watching. If you found it helpful, please remember to like and subscribe. As usual, if you have any questions or concerns, please leave them in the comments.